అకౌంట్ తోటి చేస్తున్నాను. ఓకే సార్, ఓకే ఓకే ఓకే, అర్థమైంది. ఇప్పుడు నార్మల్గా మనము మీట్ ఆన్ చేసి మీట్లోనే జాయిన్ అవ్వాలి, ప్రజెంట్ కాకుండా. ఓకే ఓకే ఓకే, ప్రజెంట్ నౌ డైరెక్ట్ మనము జాయిన్ అయిన తర్వాత ప్రజెంట్ నౌ పోవాలా? ఓకే సార్, థ్యాంక్ యూ థ్యాంక్ యూ. Good morning. May I audible to you? Hello. May I audible to you? Okay, thank you. So today I'll give the various types of the distribution system depending on the connection schemes wise. Okay, first one is radial type, another one is loop type, like a integrated type. So radial type of feeder, radial type of distribution system is having the radial type of feeder. Okay, in this system separate feeders are radiated from a single substation. Okay, the circuit is shown here. See, this is about the circuit. Okay, a single substation is having the 4 feeder pattern or 3 feeder pattern. Here 3 feeder pattern is there. Suppose I am saying, so 1 2 3 feeders. Okay, so I am taking the from the substation point 3 points I have. From the 3 points 3 feeders I have. Okay, I am assuming 1 point, I am taking a O as a 1 point. Okay, O to C is a one distributor. Okay, O to C is a supplies a distributor. Okay, O to C is a feeder, and O to C is a feeder, and which supplies the power to the A to B. Okay, so A to C is a feeder, but we don't have the any, so feeders are not having any tapping, but for the distributor we have the connection. Okay, so automatically, so figure 1 shows that this is about the single line diagram of the radial feeder, radial system. For DC system, where a feeder OC supplies a distributor and is fed at any point, only point A in. See, distributor is fed at only one end, other end is connected to the other feeder. So when power is not there, automatically we have the another connection from that. Okay, so this is about the one. And And the figure 2 is, this is about the AC distribution system. Okay, AC distribution system from the feeder out to the O to A is a feeder. From the feeder out to the, we have the distribution line A to B. Okay, so A to B we have the connection. Okay, this is about the AC distribution system. So here we don't have the transmit. Here we don't have any conversion devices and step down and step up. Why? This is about the DC. When you come for the AC, you need the transformation, you need the conversion. Okay, low high level to the low level or low level to the high level because of the distribution systems pattern. Okay, distribution systems pattern. And this is very simplest one. This radial feeder configuration is having highly usable. But why highly usable is nothing but which is having the lesser initial cost for the establishment. And simply you can understand the how the power is going to distributed. And when one power is lost, okay, during the feeder, if any power is lost, if any fault is happening, any fault is happening due to thunders or due to anything, okay, any fault is happening means automatically total system may collapse. This is about the drawback of a radial type of feeder. Okay, so coming to the drawbacks of this is the end of the distributor nearest to the feeding point will be heavily loaded. Okay, the end of the thing is heavily loaded. Any fault on the feeder or distributor cuts off the supply to the supply to the consumers who are on the side of the fault. So when the fault is happens, automatically total connections may damage. Okay, distant the consumers at the distant end of the distributor would be subjected to serious voltage fluctuations when the load on the distributor is changes. Okay, so the customer at the distinct end of the distributor last end is having the serious voltage fluctuations. Okay, when the load is on the distributor changes. Okay, distributor, if we vary see, distributor is having the different sides of connection. Because of the load variation, you have the serious voltage fluctuations. You have the serious voltage fluctuations. So this is about the one fault. Okay, because of this particular issues, okay, if the distance is increased, automatically fault identification is difficulty. Fault identification is maybe difficult. You will get a fault identification as a difficult. And you can have a more amount of voltage drop throughout this feeder. So because of these limitations, okay, this radial type of feeder is used for short distances only. Okay, for the 10 kilometers or 20 kilometers, we can use up to 3 to 4 kilometers, up to 3 to 4 kilometers or 5 kilometers, we can use a radial type of system. Okay, so coming to the ring main type of system. Okay, this is about the ring main type of system. Okay, so the main type of this is nothing but a loop type. Okay, so loop circuit, what is loop? Where you have started, there you have ended means that is about the loop. Okay, so the loop circuit starts from the substation bus, makes a loop through the area to be served, and returns to the substation. Where you have started, from the substation you have started. Okay, from the substation to the, I have the again substation, I have the again the load is ended. Okay, throughout the, see here, this is about the single line diagram of the radial main type of thing, like loop type. Okay, so I'll tell you I have the substation here. Okay. From the S point, we have the distributor feeders connection and we have the distributors connection. This is about the one feeder I have taken, and this is about the distributor L, N, P, okay, L, M, N, O, P, Q, R. Okay. So like this, we have the first I am starting L. From the L, I have the connection like this. Okay. Here, from the M point, from the M distributor, for the M distributor point, we have the distributors lines. Okay. See here, various loads are connected. Here, from the O point also, okay, from the O point also, you have some from the O point also you have this particular thing. Okay, and from the Q point also you have this particular thing. Okay, like this we have the distributors, and we in between the distributors you have a service mains, and you have the all those things are there. Okay, so this is about the when any feeder like L, in between the L and M fault is happens. Okay, so automatically we have the power is supplied through this L, M, N, O, P, Q, R. Okay, like that I have a power, and which is having the highly protected devices. So when one side power is not there, means because of the fault, automatically you have other way of thing, other way of supply connection is there. So like that we have the this like that we have the this type of thing may happen. So I told you about LMNO, PQRS. Okay, so distributor points are tapped at the MOQ of the feeder through the distribution transformer. Okay, so feeder line is there, you have a tapping, the through the M and MOQ line, you have a, from that you have the distributor. Okay, this is about the thing. So automatically, which is having higher amount of efficiency, when fault is happening within a couple of seconds you can determine the fault. Okay, so this is having more advantages when compared to the radial type of feeder. Okay, so and there are some advantages for the this particular type of thing. So this particular type of thing is having, first advantage is less voltage fluctuations at consumers terminals, and the system is very reliable as each distributor is fed from the two feeders. Okay, each distributor is fed from the two feeders. Okay, when one feeder is having some fault, automatically you have a another power supply from the another feeder. Okay, in the event of the fault on any section of the feeder, the continuity of supply is maintained. Okay, if LM is having a fault, so you have a another M and N. Hello, M and N connection. So this is about the radial main type of thing. Okay, and the this is also having some losses. Okay, this is also having some power losses. Because of that power losses, I will go for the integrated type of thing, like which is having a radial type and which is having a ring main type of thing. Okay, so this is about the third one, interconnected system. Interconnected system, when the feeder ring is energized by the two or more. So there previously ring main type of system is having, like loop type of system is having only one substation. Here I am using more amount of substations. So that is nothing but a interconnected systems. Okay, when on the substation side you have some fault, you have another connection. Like that, our our Warangal city is having the power, our Warangal city is also having this type of connection. Okay, this type of connection. For our household purpose, we are using radial type of distribution. Okay, all the transformers are connected as a loop type of thing. Okay, and all the substations are like a interconnected type of thing. All of you remind this. Okay, one is all the household purposes, like one actually nearby your home, one transformer is there, pole mounted transformer is there. Okay, that pole mounted transformer is having the connection to the some domestic loads, okay, some industrial loads. Okay, those are connected like a radial type of thing. Okay, radial type of thing. All are having the protecting devices, all are having the protecting devices. Because of the protecting devices, if one circuit is failed, heavily failed, means you have a power loss in your home. Okay, your neighboring is not having power means, okay, because of some interruption is there means automatically you will also affect with the voltage drop. That is about the radial type of connection. All these pole mounted transformers, like some area is having one pole mounted transformer, some area is having some amount of pole mounted transformer, like that. Okay, all the pole mounted transformers are connected as a loop type of thing, like ring main type of thing. Okay, and all the substations are connected as a interconnected type of thing. Okay, like this. Okay, where the feeder ring is energized by two or more more than the, like two or more than the two generating stations. I'm calling as a generating stations. Why means we are getting power from that. Okay, so this is not a generating station. I am calling a substation. Okay, substation, it is called as interconnected system. Okay, so this is about the single line diagram of that. Okay, ABCD are the interconnected feeder ring. Okay, from the feeder ring, I have a feeder ring is connected to the S1 and S2 substations at the D and C terminals. S1 and S2 is having the feeders connection like D and C terminals. So distributor, in between that you have a distributor points, feeding points are P, Q, R, O. Okay, if any fault is happens at the distributor N, automatically which is isolated, which is isolated by the thing. Okay, so distributors are connected points to the OPQR of the feeder ring through the distribution transformer. Okay, see, without the transformer we can't get the any power. Okay, so this is having more advantages when compared to the ring main type of thing and radial type of thing. Okay, why means those are having both, like ring main type of thing and radial type of thing. Okay, so it increases the so that advantages are, it increases the service reliability. See, day before yesterday or 1 week back, we have heavy amount of rains in the Varangal. Okay, so there are affected areas are there. They have some interruption because of the damage of the substations. Because of the some areas also having some areas having huge amount of floods, and because of that floods, some substations are in the water. Okay, some substations are in the mud. So substations are constructed nearer to the locality areas. Because of the land availability, they have constructed nearer to the mud. So because of the mud increasing mud water increasing level, automatically substation may having the water consumption. Substation is in the water. Okay, so within a half a day, uh, the our distribution company NPDCL is going to give the power to the that particular areas. Okay, so
Papa toys are not that.
hmm, yes.
Toys.
Madhavi, Madhavi, మాధవి ఒకసారి శ్రీమాన్ని రానియకుండా చూడు. And next one is any area fed from the one generating station. Generating station is nothing but a substation. During peak load hours can be fed from the other generating station. Okay, if higher amount of power is there, peak load is nothing but much higher amount of power is used. So automatically we have shifted some loads to the other substation also. Okay, that option is there with the interconnected system, and this reduces the reverse power capacity and increase the efficiency of the system. Okay, this is about the different types of feeders. Okay, there are some different types of classification is also there. Okay, I'll tell you that. I'll summarize this. Distribution feeder, I am again going for that. Distribution feeder in practical I am saying. Okay, practical wise I have taken a, this is about the feeder type of connection. Okay, this is about the feeder setup, practical feeder setup. Okay, that's why I am going for the PPTs. So distributor system, let's take a look on to the foremost common distribution feeder side. Okay, previously I have gone through the three type, like radial type, ring main type, and ring main type, as well as what, interconnected type. Okay, here also we have four amount of thing, like loop type is also having some separate thing. So this is about the thing. There are few other variations, but we will stick to the basics one. Okay, so it is a very important to understand why and where each of distribution feeder systems are used, because whatever you do, design of substation, secondary substations, performing the testing of this secondary switch gears or transformers, this would be the very first thing to know. Okay, this is about practical feeder setup. Okay, from the main supply we have the connection here. Here only 4 feeder patterns are there. See, first feeder level, second feeder, third feeder, fourth feeder. We have a connection to main wire connection to this particular thing. Okay, so I have this particular thing, like this is about the other names. Radial type. Radial type is nothing but many distribution systems operate using a many distribution systems operate using a radial type of system. A typical radial feeder system is shown in figure. This is about the figure. See, this data I have collected from the NPDCL. That's why, see, basic thing we have the radial type and the loop type, all those things are there. Those things I am explaining. Okay, right now we have the 2020 distribution system. Only they are using the radial type, ring main type, and interconnected type. Okay, this is about the basic thing I am explaining. Radial type. Many distribution systems operate using a radial type of feeder system. A typical radial feeder is shown in figure. Okay, Radial feeders are simplest one and least expensive, both the construction and their and for their protection. Okay, and the advantages, a fault advantages is it should however is offset by the difficulty of maintaining the supply in the event of a fault occurring in the feeder. A fault would a fault would result in the a fault will result in the loss of supply to a number of customers until the fault is located and cleared. The number of the next level of reliability is given by the parallel type of feeder. Okay, so this is about the thing. This is about the single line diagram. Previously I have shown the substation. This is about the substation. Okay, here I have the substation. Here I have the substation. From the substation you have a one bus bar. One bus bar. That bus bar is connected to the, okay, bus bar is nothing but a feeder. Feeder is connected to the one circuit breaker. Before the distributor's heading point, you have one circuit breaker. Okay, after that, four distributor points are there. 1, 2, 3, 4. Okay, see that distributors also having, the distributor lines also having individual circuit breakers. 1, 2, 3, 4. Okay, so if any fault is occurring
జాయిన్
here.
అవ్వాలండి. లేదు లేదు.
Hello, చెప్పండి. Hello, hello. Somebody is disturbing, I think. Okay, thank you, thank you, thank you. So if any fault is occurring here, through the circuit breaker, you can you don't have any problem, but you have a problem. You have a problem throughout the feeder. Okay, this is about the reliability purpose. Okay, so this is about so whenever you are choosing any type of thing, automatically you are not selecting for the radial feeder configuration. Okay, like so this is mainly used for the a group of homes. Okay, and loop type of feeder. This is nothing but a parallel feeder. Okay, so which is having greater level of reliability at a higher cost. Okay, which is having more amount of flexibility to use, but which is having more amount of flexibility to use, but automatic. Hello. Parallel feeders are more common in urban areas or for feeders to large single customers where load shedding in an emergency may be possible. Okay, this is about the loop type of thing. From here I am going to start. Okay, and you have a different amount of load connection. Okay, load connections are there because of the industrials and some amount of consumers are there. All are having the highly protected circuit breakers and which is having the substation to the substation connection. Okay, and this is about the loop. See here, from here I am starting, from there it is ending. Okay, so this is about the connection loop type of feeder. Okay, to improve the reliability factor for the loop type of thing, it may possible to have the separate sets of cables following different routes. In the case of capital cost, is double than the radial type of feeder, okay, but which is having the greater reliability when compared to the radial type of feeder. Okay, this may be justified if the load is higher. Okay, when you are using, okay, if a a group of customers, okay, those customers are having more industries, automatically I'll not go for the radial type of system. You may go for the loop type of system. Okay, instead of going for the radial type of system. Okay, so this is about the one type of thing. And in the last one, if any due to fault, any feeder is affected, automatically you have another way of power coming. Okay, parallelly we have another way of connection to the other feeder you have to use the power and to give the continuous power supply to the load. This is a one main advantage for the loop type of thing. Okay, ring main type of thing, this is both are there. Okay, like radial type as well as loop type. Okay, see, you have some advantages, you have some disadvantages, but which is having which may use for the urban and industrial environments. Okay, so at the start and finishes at end like a ring, like a loop, and power is delivered by the both the parts of the ring into the substations located around the ring. Okay, so whenever it should be having a fault occur on a feeder cable at any point around the ring, the faulty section may be isolated by the operation of the protecting circuit breakers, at the same time maintaining the supply to the all the substations on the ring. Okay, I told you about that. See, you have a two substations, all are connected to the circuit breakers. One is connected to the another sub, so zone type of circuit breakers like distribution substations, secondary distribution substations, all are connected. If one area is not having the power due to the fault, you have another connection to the, you have a, there is a chance of getting the power to the power from the another substation. Like that we have the connection in the urban areas. Okay, this like this we have working. And in current practice, okay, this is very very important. In current practice is to use the distribution automation, where operation and supply restoration in the feeder rings is done automatically by centralized controlling supervisory system like SCADA. Okay, by the using of SCADA. Okay, if ring main type of system is there, automatically you are going to have a SCADA where the power is having high load. You need to use that particular type of thing. Automation things are there. Okay, so the main advantage of the ring main type of thing is voltage drops are reduced at various loads of substation, and alternate path is available if the primary one fails to the each load substation. All of you remember. Okay, so if any remote area also is connected to the ring main type of thing, so automatically their power loss is there. If any shutdown is there, automatically you have another power line, you have another chance of getting power to particular area. Okay, like this we have that. And another one thing is mesh type. Okay, this is a very very important one. Okay, so in transmission and substation subtransmission system, usually parallel ring or interconnected mesh type of systems are used. Okay, like at the transmission line, at the transmission to the distribution side, we are going to use the one connection. Those things are meshed type of thing. This ensures use that alternative supply can be made to the consumers in the event of the failure of the transmission line or element. Okay, the extra expense can be justified because of the much greater load and number of customers that are affected by the failures of the lines at transmission or sub-transmission level. See, uh, 1 week back, you have a lot of we have Orangal is affected with the huge amount of rains. Okay, so in the year of 2016 also, September 22nd, on the day of September 22nd, same amount of flooding is there. So there are continuous power loss is there for the whole city because of the damaging of the transmission line. Okay, within a 1 day, within a 1 day, all are covered, and we are getting the power from the discoms. Why means those are connected to a measured type of systems. Okay, the general rule is that where large loads or number of customers are involved, then some form of standby in the form of deliberate redundancy inbuilt into the network design through the use of parallel mesh or ring type of system. Okay, so for the standby purpose, if any number of loads are increased and large loads are there, automatically you may shift for the parallel type, mesh type, and ring main type of feeder. Okay, this is about the clear picture of the measured type of thing like loop type. But there are more amount of feeding points are there, more amount of transformers are there. If at a T1 T2s are the transformers, F1 F2 F3 F4 F5 F6 F7 F8 Fn, all are the feeders. Okay, in between that you have a circuit breaker. At a feeder, one fault is happening, automatically at a F3 T1 transformer is connected, at a F5 you have a T2 transformer is connected. So automatically at a F3 level, I have a fault. You have a connection to the F2, you have a connection to the F7, all are interconnected. This is like a meshed type of thing. Okay, so only outer rural areas, this is having one specific thing. Only in outer rural areas would only one consider using only radial supply at a sub-transmission level. On the other hand, simple radial supply is almost usually used for lower voltages. Okay, so outer rural areas means at the feeder level, at the urban areas, at the distribution areas, we are going for the this particular measured type of thing. Okay, this is about the different types of distribution system. Okay, um, next one is how we will calculate the AC distribution system voltage. Okay, voltage calculation. This is already studied in the PS1 subject. Okay, in AC distribution calculation, if heading points are there, okay, power factors of various load currents, power factors of various load currents have to be considered, since currents in different sections of the distributor will be the vector vector sum of vector sum of load currents and not the arithmetic sum. Okay, the power factors of load current may be given with respect to the receiving end or sending end voltage with respect to the load voltage itself. Okay, each case shall be discussed separately. Okay, so because of the power factor you can calculate the your domestic loads voltage calculation, how you are getting the power. Okay, so I am going for the first level. Power factor referred to the receiving end voltage. Consider, so this is about the thing you have. Are you studied this? Hello, are you studied this? Hello, I'll brief that. Why means this is this is also having one important thing in the second unit. So consider an AC distributor. A to B is a one distributor. Okay, in between that tapping point is CB. Okay, C and ending point is B. Tapped off at points are C and B. Okay, so at a tapping from the A to C, sending end to receiving end. Okay, tapping point A to C. Okay, from the A to C, which is having some current. Okay, tapping point is there means you have some current. Because of that current, it is having some power factor. And for the B point also, you have some power, you have some current, and you have some power. Because of the distances, you have some resistances also. R1, X1, A to C, and R2 and X2. Okay, so I am going for the calculation point. Impedance of the section AC is equal to impedance, you may represent with the Z. Z is equal to R1 plus JX1. Impedance of CB is equal to R2 plus JX2. Okay, load current at C point is equal to, this is about the vector sum, vector value. I1 bar is equal to I1 into cos theta minus j I1 into sin theta. Okay, when I take the I1 as a common, I1 into cos theta 1, phi I have taken cos phi 1 minus j sin phi 1. Because of that particular C feeding point is having phi 1 amount of power factor. Okay, I2 is equal to load current at the point B is equal to I2 is equal to I2 bar is equal to I2 into cos phi 2 minus j sin phi 2 you will get. Okay, I need, this is about the current connection. Okay, I need total AC current. AC current is equal to both the sum. Okay, so it, see here IAC is equal to, you have the division at this particular point, I1 and I2 is distributed. So IAC is equal to I1 and I2. IAC is equal to IAC bar, Y bar, that is about the vector sum. I1 cos phi 1, I1 into cos phi 1 minus j sin phi 1 plus I2 into cos phi 2 minus j sin phi 2. Okay, so I am going for the voltage drop calculation. Voltage drop calculation is equal at C and B level is equal to ICB into ZCB. You have the configuration, you may do that. I2 into cos phi 2 minus j into sin phi 2 into R2 plus jx2. Okay, VAC is equal to IAC into ZAC. I1 plus I2 into I1 bar plus, what I am saying is I1 bar plus I2 bar into ZAC. Like this, we have a combined calculation. Okay. At the sending end voltage is equal to VA is equal to VB plus VCB bar, VB plus VCB plus VAC. And sending end current is equal to IA is equal to I1 plus I2. Like this, we have this is about the vector diagram of that. Okay. You have a different levels of thing. Okay. Voltage drop calculation with respect to the receiving and respective load voltages. Okay. Suppose power factors of the various, I'm taking phi 1 is a phase angle between the VC and the VD. So you have a different types of calculation. These are already studied by you. Okay. Up to now, you have studied about the different types of classification, different types of distribution feeders. And tomorrow, I'm closing now. Tomorrow, I'll say about the what basic design of the secondary distribution system, and uh, voltage fluctuations levels, and what are the factors you may have the feeder loading, and what are the factors. So how you will have the feeder loading? Tell me. Feeder level is decided by the what are the things. Hello. Load. Very nice. Thank you, Ashish. Load. Load requirement. Next. Basically, load requirement. Okay. If the load is having higher amount of voltages, high level, okay, because by the using of the substations or step up transformer, you may increase the level. Okay. And because of the continuous available, see, feeder loading is having various factors like load usages and continuous load increment wise. Feeder is also feeder limitations. See, one feeder is having 11 kV, another feeder is having 32 kV, another feeder is having the, only those things are there. How to load that feeder? How to load that feeder? Because of the transmission and because of the distribution of the power purpose to the different sets of loads, as well as, see, there are feeder feeders are there, one substation to the distributor, then in between that you have some feeder. Okay. So if our college is there, our college requirement right now is having lesser amount of power, but our college is connected to a uniform like express feeder. Okay. Express feeder only, this is about the one type of feeder. Express feeder is nothing but like there is no tapping, but we have a continuous power, for that. Okay. So our college is having right now, current situation, we are not going to the college, there is no power requirement. How we can load our college? Because of the various factors. Okay, that feeder level or that feeder loading, see, uh, 5 months they will take the historical data. Okay. because of the historical data because of the historical data, and because of the load increment during the peak hours, because of the load load requirement and future load increment also considered, and feeder voltage feeder loading is possible by the using of all these things. Okay, how to load a your own system for your home purpose. Okay, you have only one light and one fan is there, like single bedroom. Okay, single bedroom is having one light and one bulb is there. Okay, when you have shifted to the double bedroom, your electrical appliances are more like geyser type of things are there. Automatically you want to increase your level. Okay, depending on the load increment your tariff may increase and your total feeder possibility is there, feeder requirement is there, but feeder requirement, feeder loading is high, but the feeder sending voltage is same, but we are by the using of the secondary and secondary distribution transformer, we are going to step down in the voltage. This is about the loading of the feeder loading. Okay, and voltage levels. See, this is another question I have. Okay, we have 33 kV, we have 33 kV, we have 11 kV, we have 6.6 kV. Like this we have the different amount of thing. Okay, are you know about this? Okay, what is traction, traction voltage level? Traction voltage level, yes, 25 kV. Thank you Sai Pujita, great. 25 kV. Okay, are you went to any diesel locomotive units? Any locomotive units? See, I have some PPT. So for the Indian Railways are using 25 kV. So this is about the in the year of 1881, Indian Railways are coming to the picture. Okay, and so India electrification is 44%. Okay, when you go for the other, see, if you see the Italy 59%, Sweden 59%, Australia 59%, Amtrak 100%. Okay, this is about the feeder circuit. That's why I am going to this. Okay, 250 kVA or so. This is about the 6 kV line. This is about different types of electrification, and this is the main diagram of the electricity, how a electric traction in motor is going to get the power, and a engine is going to get the power by the using of the pantograph and circuit breaker and tap changers. By the using of rectifiers, DC motor is going to go through the DC motor rotating, that is fed to the machines. Automatically it may grow. So 1.5 kV at the DC and 25 kV at the AC. okay, for the main line, okay. And in our india in our india 1.5 kV dc overhead system is there, okay, which is used in the Bombay, okay. This includes Bombay, Bombay, Pune, Belpur. Like that, we have the 1.5 kV DC. Okay. And in Calcutta Metro, 750 volts DC traction with a third rail mechanism for delivering the electricity to the EMU. Okay. Like this, we have the 25 power. Okay. These things you will study in the utilization subject. Okay. This is about the power track. Right now, I am today you have gone through the distribution systems classification. So I am going for the sign outing. Stay home, stay safe, don't go outside. Okay, COVID is attracting you. Don't go outside. Stay home, stay safe. Thank you very much.